We have now learned how to create variables and assign values to them. I want to return to a very important point that distinguishes the codecast tool that we're working in right now, that we're using to record these lectures and that you're using to watch these lectures, and other tools that you might use later on for C programming purposes. Let's start by reviewing how to declare and assign values to variables. To declare a variable, we typed int for an integer type variable, and then the variable name. I'll just call it variable for now. So this is also called the variable declaration. In order to assign a value to the variable, we then type the variable name, an equal sign, and the value that we wish to put into the variable, so 2, for example. So this is the assignment, or we can call that the definition, or because it's the first time the variable gets a value, we also call that the initialization. So all is good, but what happens right after this line has been executed? So the variable has been declared, but we have not yet assigned a value to it. And that's where codecast differs from other tools that you might use later on. Codecast automatically assigns a value of 0 to the variable after it has been declared. So at this stage in codecast, variable will have the value 0. This is not true in other C programming utilities. In particular, this is not true in the tools like TaskRater that we will be using to validate the code that you submit in this MOOC. And so this is not something to get used to. It's a nice feature of codecast, but not something to get used to. Instead, whenever you declare a variable, you also should initialize it right away, so that you never find yourself in a situation where a variable has been declared but not initialized. Whereas codecast automatically initializes as 0, other tools will not. So what would variable be in one of these other tools? It turns out variable is just a memory box. So what happens when you declare a variable, space in memory is reserved to hold whatever you place into that variable. But whatever was sitting in that memory location from a previous run of a program or from who knows what else was just happening, that would then be interpreted as the current value of your variable. So you got to make sure you overwrite it with a variable value that you actually want to store in there, rather than keeping in there whatever garbage is left from a previous program execution. So this is really important. In particular, in TaskRater, the tool we use to validate your code, variables will not be automatically initialized. So best practice, whenever you declare a variable, you also initialize it. In fact, this is so important that you can actually do this in one step. So you can actually type int variable equals 2, and that is a variable declaration and initialization all in one step. Then nothing can go wrong. Even codecast can't get in your way and do anything for you. This one line declares and initializes a variable all in one step.
Let me show you how you can create a variable and assign a value in one single instruction. In this program, we first create a variable balance containing integer values, and then we do assigning the value 50 in the balance variable. So I'm going to do both creation and assignment at the same time. So first, I'm going to define what's the first line. It's a declaration, and the second line is a definition. Declaration is we declare an integer variable and we put the name. Definition, well, we only put the name and then we assign a value. So for a declaration, you have the type in integer and you have the name. For the definition, you have the name, you don't have the type, only the name, and we assign a value. So we can do both declaration and definition in one single line, like this. And I can get rid of the definition. So what I did here is I declared a variable with a name, balance, and I defined it by assigning a value. And that's how you declare and define a variable at the same time. If I compile and run, it works. So you can see here the third line is how to use the variable. That's how you declare and define in one single instruction.
I would like to give you some advice on how to choose good names for your variables. In this example program, I chose the variable name balance and then gave it the value 50 because balance represents how much money is in my bank account. Here in this printf statement, you see it'll print out I have %D. The %D is replaced with a 50 that's stored in balance. So I have $50 in my bank account. So that's why I chose this variable name balance. It is an explicit name that says something about what's stored in this variable. So the first rule is to choose an explicit name. But there are certain restrictions in C on your variable names, and I'll put those in a comment right up here. So variable names can use lowercase and uppercase letters or characters and digits. But they cannot use special characters such as the @ sign or the pound sign or the ampersand sign and so forth. They can also not use accented letters like an E with an accent on it. And this is an important one, they cannot start with a digit. So they have to start with a letter. Spaces are also forbidden in variable names. So if you wanted to call the variable my balance, you could not type my space balance. However, an underscore may be used instead of a space in the name of a variable. And so how do you do that? If you want to have a variable name that consists of several words, you can simply stick all those words together using uppercase letters between the words instead of spaces. So you can use uppercase letters between words instead of spaces. So let's look at some examples. Suppose you wanted to call this a valid balance. You can't just say valid space balance. That's an illegal variable name. If I were to try to compile this, it would actually give me an error message. What you can do instead is place an underscore instead of the space character. Now valid balance with the underscore in the middle is a legal variable name. Of course, I'll have to update it all over the place in my program. Otherwise, my program doesn't know that I just chose a new variable name. But now that I did that, I can actually compile and run this program, and it runs just fine. I have $50 in my bank account. There are other ways to deal with the fact that you cannot use spaces. One of them is you just get rid of the underscore, but now that's really hard to read. And so what you can do instead is you just uppercase the beginning letter of a next word. So valid balance here with a B uppercased indicates that I really meant two words, but I couldn't do that. And now if I change this all over the place again, then my program runs just fine. I just replaced my variable with this new variable. So let's check this out, compile and run, and it works just fine. I have $50 in my bank account. It's a personal preference on whether you prefer to use an underscore or just smack your words right together by uppercasing in the middle. It's a real personal preference. It's up to you. But what's really important, you need to be explicit with your variable names. Choose names that indicate what the variable is all about and what it's used for, so that people reading your code can understand it more easily. And in addition, your variable names need to follow all of the rules that we just saw above.
Let me show you the most common errors when you use variables with a compiler. Here we have a simple program that do a declaration here of a variable, and then a definition, and then we use it here. If we compile and run, we have in the terminal, I have $40 in my account. Good. Let's try to forget the type definition here, int. So I only have the name of the variable for the declaration, which is quite an error. If I compile, well, I get multiple messages here. Let me copy paste to understand what's happening. First one is error, use of undeclared identifier balance. And this is line number 3. Indeed, line number 3, there is only the name of the variable. So the compiler thinks that we want to use a variable that exists that was already declared, but it's not declared because we didn't define the type, which means that we forgot to put int to declare the type of the variable. All right, so that's the first error. If I compile now, it should be okay. Yeah, runs okay. Second one I want to show you is I forget the definition. So I just get rid of this line, and I have only the declaration, and then we use the variable. If I compile, then I have also messages here. Let me copy paste to show you what's happening. Going back to edit mode. So here it's a warning. Warning variable balance is uninitialized when used here. So you can see here that when we use the variable, well, we use it, but we didn't put any value in it. So what's happening here is that by default, it will put a 0 because we didn't put any value. But this is absolutely not true with standard compilers of the professional C compiler. They won't put any value at all. So you would have a random value. So you have to be very, very careful if you have this warning, and if you use variables that are not defined or you forget to put a value, then in the codecast and in some compilers, sometimes you will have a 0 by default. This is absolutely not true with all the compilers, professional compilers. You will have random values. So it's very important to see this warning and to correct them when you have them. So here, when you use a variable that is uninitialized, well, you should initialize it, meaning that you should put a value, meaning that you should define a value for the first time, initialization. All right, so now if I compile and run, it works okay. Something else. If you use lowercase and uppercase and you mix them, for example here, let's put a B uppercase. Compile, and here we have multiple messages. Let me copy paste them. The first error is use of undeclared identifier balance. And look at here what's written. Did you mean balance with a B uppercase? So it's pretty smart here because it knows that you have a declaration of a variable with a B uppercase. All right. The other one, we won't go into the details. So here we can see directly that we have to use a lowercase b. I guess if we do the same with definition, if I compile, well, I have the same kind of messages. Use of undeclared identifier balance. Did you mean balance with a b lowercase? So this is quite explicit and will be very easy to figure out. Also, something else. If I declare one with a b lowercase and declaration 2, and another one with a b uppercase, then I define the first one and I define the second one, and then I use the first and the second one, And look what happens here if I compile and run. Well, you can see that it is case sensitive, meaning that we have two variables, one with a b lowercase, one with a b uppercase, and both of them are working. So you have to be very sure of using lower or uppercase letters when you name the variables. That's pretty much all I have to say when you use the variables and all the different errors you can have. Maybe you can try to have a different kind of error. So try to do something here to get an error and try to see if you understand the error. If you try to to generate new kind of errors and tell us in the forum if you found some of them.
So far, we have learned about variables and we have learned about loops. I will now show you how to use variables in conjunction with loops. To do so, let's look at the following scenario. Suppose I'm taking a hike in the forest and I'm hiking for, say, 9 miles. Every mile, I pick up 3 hazelnuts. And I'd like to print out how many nuts I have in total after each mile. So to do so, I need to store two quantities, how many nuts I have at any point in time and how far I have traveled. So let's do that. Let's declare two integer type variables, one of them being the number of hazelnuts. And whenever we declare a variable, remember we should also initialize it. And initially I have none, I haven't collected any hazelnuts yet. And then another variable that stores how far I have hiked so far, so distance traveled. And again, at the beginning of my hike, I haven't traveled any kind of distance yet. So now every mile, at mile 0, at mile 1, at mile 2, at mile 3, and so forth, I would like to print out how many hazelnuts I have collected so far. That sounds like a loop to me. So let's paste in our typical loop statement. For I equals 0, I less than 9. I'm going to repeat this loop 9 times. That's why I put in 9 here, I plus plus. And we're going to need a closing brace at the end of this loop. And then we have to put something in there. Now remember, whenever we have this loop, the I that you see in here is actually a variable. We haven't really spoken of it as a variable, but I need to declare this variable just like I need to declare any other old variable. So we'll understand that more later. For now, I'll just put it up there. So here's my loop. 9 times I want to repeat something. What is it that I want to repeat? Well, I'd like to print out how many hazelnuts I have. So I need a printf statement that says that at so and so many miles, and this %d will be replaced by 0, 1, 2, 3, and so forth. So at %d miles, I have, and then whatever many hazelnuts I have. And let's start a new line after each statement so we can read it more easily. So now I need to put in what these %ds should be replaced with. Well, it's the distance traveled for the number of miles. So distance traveled right here. And for the number of hazelnuts, I called that variable number of hazelnuts. And that's it. So that's a printf statement that prints out how many hazelnuts I have at a certain distance. But now I need to update these variables. Initially, I initialized them as 0, but they don't stay 0. After the first mile, I have actually collected some hazelnuts. So I need to change what's stored in number of hazelnuts as well as change my distance traveled. So after each printf statement, I need to actually increase distance traveled by 1 so that I'm getting ready for the next printf statement. So how do I do that? I write distance traveled equals, and now I need to state an update statement. Distance traveled plus 1. Now that looks really weird, right? That doesn't seem mathematically true. You can't say distance traveled equals distance traveled plus 1. But remember, this equal sign is not a mathematical equality, it's an assignment statement. It means that we take the right-hand side evaluate what's on the right, and assign the result of the evaluation to the variable on the left. So the first time we're in this loop, distance traveled is still 0 from my initialization. So this variable here has the value 0. We're taking that 0 by adding 1 to it. So the right-hand side evaluates to 1, and that value is then assigned to distance traveled. In other words, distance traveled is updated with the value 1 if it previously was 0. If it previously was 1, then it would be updated with the value 2, and so forth. So this statement updates distance traveled by increasing it by 1. Similarly, my number of hazelnuts needs to be updated. And how does it need to be updated? Well, I collect 3 hazelnuts for every mile that I travel. So I need to add 3 to the current number of hazelnuts in order to get the new number of hazelnuts. Number of hazelnuts plus 3. And now I have updated both of my variables, and my loop is complete. I'm printing how many hazelnuts I have at a certain mile, and then I'm updating my distance traveled and my number of hazelnuts to get ready for the next printf statement. Let's compile and run this code. And it says at 0 miles, I have 0 hazelnuts and a lot of other stuff. So let's go through this slowly. Remember, initially, the number of hazelnuts is 0 and the distance traveled is 0. That's how I enter my loop. So the first time I get to this printf statement, distance traveled is 0 and number of hazelnuts is 0. And that's why it prints out at 0 miles, I have 0 hazelnuts, the first statement you see in the terminal window. Next, I update distance traveled by adding 1 to the old value of distance traveled. So 0 plus 1 is 1. Distance traveled now has the value 1. And then number of hazelnuts is updated by adding 3 to the old value 0. So 0 plus 3 is 3. So distance traveled and number of hazelnuts now have the value 1 and 3 respectively. And a loop means that these 3 statements are being repeated over and over and over again. So next I get back to this printf statement, but this time the new values are going to be printed. So it's going to print out at 1 mile, I have 3 hazelnuts. And that's what you see in the second line that got printed out. Then distance traveled is updated again and now becomes 2. Number of hazelnuts is updated to have the value 6. And we get back to the next iteration of the loop with the printf statement. It now prints at 2 miles, I have 6 hazelnuts. And it keeps going and going and going like that until I get to at 8 miles, I have 24 hazelnuts. Why did it stop at 8? I wanted this loop repeated 9 times. Well, it actually did repeat 9 times because we started at 0. So 0 gets printed out during the first iteration of the loop. 1 gets printed out during the second iteration, and so forth. 8 gets printed out during the 9th iteration of the loop. So the loop was indeed executed 9 times. So this is how we can use variables inside loops.
I'm going to show you how to read the input of a terminal to ask something for the user, and that the user is writing the answer in the input, and then we read the input. Here we have a very simple program where we declare a variable age, we define it, and then we use it. If I compile and run, in the output we have you are 17 years old. Good. Now I'm going to show you how, instead of defining with a fixed value here, I can ask the user, for example, for its age. And what I can do is do first a printf, what is your age? With a \n. And then I'm going to use something called scanf to scan the input. It looks like a little bit like the printf, so I have to put opening and closing parentheses, and I have to put quotes. And within the quotes, I will only put something very simple, what I want to read as a format. And I want to read a person D. And this person D, what I read in the input, I want to put it in the variable age. And to say that, we have to use a special character, ampersand. So ampersand and then age, without any space in between the ampersand and the name of the variable. And then let me finish with a semicolon. And that's how you read a value with a %d, and you put that value in this variable age with the special character ampersand here. So now I don't have to define it again, because I will get the value from the scanf, from reading the input from the terminal. Let's compile and run it to see. And you see in the terminal that there is the question, what is your age? And I have to input something, a value. Let's input 17 and then type enter. And as you can see, the printf, the last one, use the value of the variable that was just set by the scanf. And it says you are 17 years old indeed. So that's how you read with a scanf the input from the terminal. It's pretty much like the printf with the quotes here, but you don't put anything else than the %something that you want to read. And then you put the name of the variable with an ampersand, and that's pretty much all about it. If you want to define multiple variables, then you will use multiple scanf. So try it yourself, try to compile and run it yourself with your age to see if it works, and try to use it with another variable, for example.
You can print multiple, just like you can print multiple integers using just one printf statement by simply using multiple %d format specifiers. You can also read multiple integers from the user input using one scanf statement with multiple %ds format specifiers. Let's take a look at an example. So if we want to read multiple variables, we need to declare multiple variables. So how about we have one called first, one called second, and one called third. And then we should probably ask the user to enter some numbers. Please enter 3 integers. Okay. And then we have a scanf, and we simply put a %d for the first, a %d for the second, and another %d for the third number we want to read. And then after the format string, we put a comma, and the first variable with the ampersand sign in front of it. The first variable is first, and another ampersand second, and another ampersand third. So that means that the first number the user enters will be stored in the variable first, the second one they enter will be stored in the variable second, and the third one they entered will be stored in the variable third. So let's print out what the user entered and the values of these variables. %d for a second and %d for a third. And then we need to put in our variables first, second, third. Okay, let's check this out. So let's compile this and let's run. Please enter 3 integers. How about 5, 789, and 17? You entered 5 for first, 789 for second, and 17 for third. So that worked perfectly. I want to show you something else that's possible, however. So if we run this program again, please enter 3 integers. I could even hit the return key after each integer. So I don't remember what I just entered, 5, and then 678, and I am hitting return after each integer, so 34. And it still worked just fine. 5 for the first, 678 for the second, and 34 for the third. I could even do this in some kind of mixed fashion. If I run this program again, enter 3 integers, I could enter the first one, 56, and 32, and then hit return, and then enter a third integer here, and it still read all these integers just fine. What happens when C reads integers or numbers from the user input is it simply ignores white space between numbers. So as it gets ready to read the second number, it ignores all white space before the second number. We could go even a little bit further. If I run this program again, I could even put some white space in front of the first number before I even enter anything, and then maybe enter a 45, and then a bunch of more spaces, and a 33, and another space, and 75. And it still read all those numbers correctly. So when reading numbers, the scanf function ignores white space. So that's return characters, spaces, and such. However, let me show you one more thing. When I run this again, and this time I put commas between my integers, that's not going to be good. It read the first number just fine, but then it got confused for the second number and got a 0 there and the 0 for the third number because the comma confused it. In order for the user to be able to enter commas, you would have to specify that in your scanf format string. So we could do that. If I specify that I want a comma between these numbers, I have to put that comma right there. And then I could tell the user, please enter 3 integers separated by commas. And now when I run the code, compile and run, enter 3 integers separated by commas, I could enter 34, 76, and I could still put lots of spaces here. And there we go. And that worked again because the comma is now in the place where it was expected. So you can read multiple inputs all at once with one scanf statement, and white space is ignored when reading numbers.